Okay, so this is gonna be part 2 on polymers, the big 6 polymers, but we're already past that. We're now in the previous video we stopped at 4 hours. We'll continue. So recycling. So recycle materials. You don't throw beverage bottles away um, irresponsibly. Ideally, these bottles are supposed to be shredded. If their material is, if they are made out of PET, then you can shred them. You can turn them into textiles, or you can shred these plastics. Is that the correct term? Shredding? Basically, the goal is you can make, yeah, shredding. You reprocess in order to make new PET bottles. So that's basically it. Um, for plastics that cannot be recycled, PVC and PS. Uh, in this reviewer, I didn't really write down other ways to deal with them once they're no longer okay for use. But as far as I know, I think downcycling can be a solution. Basically, mixing these plastics with other plastics for the purpose of what? More on that later. Um, so the fourth R is recover. Um, so you recover either the materials or the energy content from unrecyclable materials. So this is where downcycling comes to the picture. So for certain materials that cannot be recycled, you can actually get or salvage energy content from them. The question is how. Again, more on that later. Let's just go here first. Um, so recover fuels are usually hydrocarbons, right? And plastic actually can produce more energy than coal when you combust them. The only problem is, just like the dilemma that we face in the combustion of coal in coal power plants, CO2 is being emitted. It's a byproduct, it's inevitable. So, burning PVC or polyvinyl chloride risks the production of hydrochloric acid gas, and this contributes to acid rain. So, that's not good. Um, burning other polymers risks the release of other toxic materials, so that's not good either. This is a more generalized term to this. Okay. One example of how you apply recover is when you burn unrecyclable plastics that contain high energy. Currently, that's kind of the reason why the most popular uh, ideas when it comes to sustainability is just 3 R's: reduce, reuse, recycle, is because for recover, it's actually kind of controversial in a way that since currently it is said to be not as good as what you get from reduce, reuse, and recycling, uh, since yeah, it's basically not a good way of dealing with plastic waste. Burning or combustion of plastic isn't necessarily, considering the disadvantages, it's not good. But even so, this is still currently for research. It can help solve the energy crisis that we have in the world. So, especially in places where plastic waste is very, very common. So, landfills. Landfills make use of chemical linings or coverings that prevent leaching on the ground. Why is this detail important? More on this later. But first, we have to know that um, so it's a site where plastics cannot, uh, where plastics that cannot be reused and recycled are relocated to. So previously, the previously beneficial properties of plastics, some of which are the fact that they are long lasting, that they do not degrade easily. So this is where they become um, disadvantageous because, for one, it takes several decades for these to degrade. In fact, majority of the plastics won't even degrade at all. And in the case of biodegradable plastics, from the word biodegradable, that means they degrade by being consumed by bacteria and fungi. But in the case of landfills, because these landfills, especially modern ones, okay, we're talking about modern landfills, they make use of chemical linings or coverings that prevent leaching to the ground. So whatever plastics are on top, soil and water supply from below are not affected. So as a result, biodegradable plastics, they become pointless. They don't become biodegradable at all, because these chemical linings create an anaerobic environment in the landfills. So by the word anaerobic, that means no oxygen. So essentially, uh, although there are certain bacteria and fungi that can survive without oxygen, majority are known to consume plastic. But because there's no oxygen, they can't survive. So the bacteria and fungi that we need so that biodegradable plastics could be consumed, they won't be there. So biodegradable plastics cannot degrade. So that's the dilemma we're facing. In terms of, okay, so you have to know this. Only 3.5% of plastic in the States is recycled. So that's for a fact. Um, Here in this table, you can already see which ones can be recycled, which ones cannot. Um, Everything technically can. In this list, PP or polypropylene, I think that's what you call it. Polypropylene, HDPE or high density polyethylene, um, PET, all of these can be recycled. But for PVC and LDPE, usually, I mean, it's not common for them to be recycled. As you can see, the numbers are very different, around 30%, and here we just have, it doesn't even reach 1%. So that's how you know that PVC and LDPE aren't popular when it comes to recycling. So yeah, it's a really small number. 3.5% of all plastic in the country isn't recycled. So everything else isn't recycled. Only 3.5% is recycled. So the question begs, why is plastic not why isn't it at as popular? Why is recycling not as popular? So there are many factors that come into play: science and technology, economics, industry, and politics. So all of these must work together to constitute this recycling loop. What recycling loop is this? It's this. So recyclables turn into products. Products go to the consumers. Consumers produce recyclables from the consumed products. So this, for recycling to be successful, enough sources, you need to have enough materials to source so that you could process in bulk, because again, processing is really expensive. So to maximize, you need to process in bulk. You can get these source materials from waste collection, drop-off centers, and recyclable waste exchange programs. So you basically need a a continuous supply to keep recycling businesses running. So once collected, the plastics have to be sorted. This is extremely important. Um, it's also a crucial part in the picture of the recycling industry, because you also have to consider the marketability of the products that are to be made from the sorted materials. So if they are sorted, of course, they are more profitable if you produce products that are only made out of a single kind of plastic. If they are not made out of a single kind of plastic, that means they cannot be sorted. So it's this. If they cannot be sorted, they basically have mixes of different plastics. They are hard to purify and they are hard to sort. So the solution to this is downcycling. Um, but of course, since they are made out of different kinds of plastics, their value is a lot lower. So marketability wise, it's not that profitable. So, um, but it's inevitable in the case of PVC and PS. They cannot be recycled. So the solution is downcycling. So you convert these materials to low-grade products, parking bumpers, orange cones, flower pots, plastic lumber, etc. The only problem here is that, well, yes, I already mentioned it. Um, the products made from downcycled materials aren't as valuable as products made from homogeneous materials, plastics that can be sorted, because they are just made out of one kind of plastic. So, or in other words, they're very pure in terms of just one kind of plastic. So, yeah, that's it. Is that it? Nope. We're at the last page. Okay. So, plastics, there are also plastics that are made from renewable materials, not just ones from petroleum or ones that are petroleum based. Ren- by the word renewable materials, by the term renewable materials, they're basically made from wood, cotton, fibers, starch, sugar, that kind of sort. By the word renewable, that means they are compostable, biodegradable. So essentially, when they degrade, they don't uh, they don't oftentimes produce toxic substances. So when produced, they use less energy, they generate less waste, and they use fewer resources. And yeah, that's one of its advantages. Um, yeah. When incinerated as an energy source later, um, essentially they don't have halogens such as chlorine and fluorine that can form harmful acids as well as contribute to greenhouse gas emissions through CFCs. So some polymers can be converted back to monomers. They could be remade into virgin polymers once more. But again, production and waste processing, they're not as straightforward as you think. Possibly it's more expensive uh, in the case of processing renewable materials because some sources need a few years to actually renew. That's the reason why supply for this kind of uh, in the case of renewable materials made out of plastics is limited. So even if you use fewer resources or less energy, because it takes time for some sources to actually renew, it makes these products expensive to procure. So one example of a renewable material uh, one example of a plastic made out of renewable materials is polylactic acid or PLA. So it's used in food packaging, clothing. It's a common renewable polymer. It's thermoelastic, so polyester similar to PET. What does thermoelastic mean? Relating to elasticity in connection with heat. Okay, so it is elastic upon contact with heat. It has a much lower melting point compared to PET. That's the difference though. compared to PET. This is a similarity, this is a difference. So to give you an idea, PLA softens at 140 degrees Celsius. PET, on the contrary, softens at 250. So this makes it gives the idea that PLA is disadvantageous in the sense that it has a lower melting point. So to solve this, you combine it with other chemicals to improve its properties. Although this solution is a double-edged sword. A disadvantage that could come along with this is that it could increase toxicity. Know that PLA, again, is a plastic from renewable materials. So if you increase toxicity, it doesn't add up, right? So in that sense, by increasing toxicity, it makes it more difficult to recycle or reuse. So because part of what you get by having a higher risk of toxicity is, well, you risk leaching. That's something that you don't really see in the case of plastics made from renewable materials, but yeah, it's there. So it's harder to reuse in that sense. And when it comes to recycling, again, ideally, you recycle plastics that are pure. So when something is just HDPE, it just has to be HDPE all the way. But if it's composed of other kinds of plastics, in the case of PLA, if it's mixed with other chemicals, it makes it harder to recycle because it's not purely PLA. Okay, that's it. Thanks for watching. That's it for this video.